seafloor where there's no biology. These are interpreted as stromatolites, sedimentary structures formed by microorganisms that lived at the interface between the sediment and the ocean.
Allwood used geological techniques to interpret the environment these fossilized microorganisms may have lived in almost 3.5 billion years ago.
What we saw was that immediately before the stromatolites formed was a setting pretty much just like this, a rocky coastline. We see that the stromatolites only exist in the shallow water environment and don't exist in the deep water areas that were existing at the same time.
This fossilized ecosystem provides a glimpse into the past and what might be the remains of man's earliest ancestors.
With the rise of astrobiology and new techniques and approaches to interpret evidence for life, we can be fairly confident about saying that life was on Earth at least 3,430 million years ago.
But could life have existed even earlier on our planet?
The oldest evidence of life is not evidence of the oldest life. We do not have any geologic record for the first 500 million years of Earth's history. So there's a whole bunch of stuff missing.
What's not preserved in the fossil record is how life formed in the first place. We humans are the descendants of stardust. 4.6 billion years ago, stellar debris created vast clouds of gas within our solar system. These gaseous clouds formed dust particles, which stuck together. They eventually formed large boulders made of rock and ice called asteroids and comets. For millions of years, these bodies collided and coalesced to form planets, including Earth. During this heavy bombardment, Earth was a hot, toxic water world. But in the midst of this volatile period, life may have taken hold below the ocean's surface, in hydrothermal vents, which are formed near volcanoes. There, atmospheric chemicals and energy may have formed a cocktail of amino acids, the essential elements of life.
One of the popular hypotheses is that life arose around a hydrothermal vent because of the particular conditions there, that it would have been a deeper water environment which offers protection from impacts. Shallow water environments would have been very hostile during the period of heavy bombardment.
But the key question for astrobiology is, where did the spark occur that took non-living matter and turns it into living matter?
Chris McKay is a giant in the field of astrobiology. The NASA scientist has spent over 25 years trying to decode the origin of life on Earth and find it elsewhere.
There's a whole set of theories that suggest that everything needed for life started and was created here on Earth. So the organic material that led to the first life could have been produced in lightning discharges on Earth. An alternative theory is that the organics that led to life weren't created on Earth, but came into Earth. Comets, for example, could be a source of organics. Meteorites from Mars or asteroid infall could have been a source for organics. So now the raw materials are imported, but life is still homegrown. Yet another theory suggests that not only did the organics for life come in, but life itself might have come in from outer space. We don't really know how to choose between those three alternatives.
All life on Earth is made up of essential building blocks, including carbon, hydrogen, oxygen, and nitrogen, as well as 24 other ingredients. But the fundamental properties appear to be water and carbon.
The carbon in water model of biology is the one that we're familiar with, and it seems to be the best way for biology to operate.
Scientists think the best chance for finding extraterrestrial life is to search for traces of carbon and water on planets in our own solar system. Mercury and Venus are too close to our Sun to sustain liquid water or an Earth-like atmosphere. But what about Mars, the fourth planet from the Sun?
Studying the oldest evidence for life on Earth is relevant to the search for life on Mars. We have strong evidence that sometime in the past, Mars may have been more hospitable, wetter and warmer, had an atmosphere.
Today, Mars looks like a dusty red desert. Its atmosphere is so thin that liquid water would freeze and evaporate at the same time on its surface. But Mars's topography reveals polar ice caps, gullies, and volcanoes, including Olympus Mons, the largest in the solar system. So, could liquid water still exist beneath the surface, where temperatures are warmer? Scientists believe the best chance for finding life beyond planet Earth might be next door in our solar system. Mars, the fourth rock from the Sun, may have liquid water beneath its surface, a good signature for life.
Hydrothermal systems can definitely exist on Mars though, because we can see massive volcanoes. We know there's plenty of water still on the surface of Mars. That heat source, the water source, provides all the ingredients necessary to make microbial life very happy.
To better understand the geology on Mars, astrobiologist Dr. Adrian Brown investigates the hotspots on Earth, particularly Lassen Volcanic National Park in Northern California.
The reason I'm interested in Lassen Volcanic Park is because of these hydrothermal hotspot areas where we can find minerals that are forming that don't form anywhere else but these areas. These sulfate-rich minerals that we see in the sides of the hills here are areas that we think that are analogous to Mars, and the fact that they're still active today means that we can get an idea of how friendly they are for life.
Hydrothermal hot springs are formed near volcanoes. Deep underground, the searing heat of volcanic magma chambers propels hot water and dissolved minerals into cracks and fissures in the subsurface, which then erupts onto the surface of the Earth. The spring surrounds itself with a treasure trove of energy-laden minerals suitable for a microbial feast.
A hydrothermal spring, just like the one behind me here, would be exactly the place that we want to land on Mars. This sort of area would be just perfect for life to exist, perhaps even for life to form, the origins of life. This area where water has been forced up through conduits and carried along minerals, energy sources to the surface, and then spread them out around the deposit for microbes to feed on as an energy source.
Brown thinks if Mars is still volcanically active, similar hydrothermal areas will exist. They might be places where life may have originated or still exists just below the surface.